Scalability is one of the most important concepts in computer systems and software design. It refers to the ability of a system to handle increased workload, growing data volume, and more user requests while still maintaining good performance and reliability. Think of scalability like a restaurant that can serve more customers as it grows without sacrificing the quality of service. A scalable system can grow to meet demand without breaking down or slowing down. When we talk about measuring scalability, there are 4 main metrics we need to understand. Response time measures how quickly a system responds when you make a request. Throughput tells us how many requests per second the system can process. Resource utilization shows how efficiently the system uses CPU, memory, and storage. And concurrent users refers to the maximum number of people who can use the system at the same time. These metrics help us understand how well a system can handle growth. There are 2 primary ways to make a system more scalable. Vertical scaling, also called scaling up, means adding more power to existing hardware. Imagine upgrading a single server by adding more processing cores or more memory to it. Horizontal scaling, also called scaling out, means adding more machines to the system. Instead of making one server stronger, you add more servers and distribute the work among them. Both approaches have their own advantages and disadvantages. Vertical scaling is like putting a bigger engine in your car. You take an existing server and upgrade its hardware. For example, you might increase the CPU from 8 cores to 32 cores, or upgrade RAM from 32 gigabytes to 128 gigabytes. The benefits are that it is simple to implement and manage, and you do not need complex load balancing. However, there are limitations. You cannot upgrade a server indefinitely because hardware has physical limits. There is also a single point of failure, meaning if that one server goes down, everything stops. Plus, upgrades might require downtime. Horizontal scaling works differently. Instead of making one server more powerful, you add more independent machines to your system and distribute the work across them. For example, you might add 3 more servers to a cluster and use a load balancer to distribute incoming traffic evenly. The main advantages are that you have no hardware limits, you get better fault tolerance because if one server fails, others keep working, and it is better for very large systems. However, horizontal scaling is more complex to manage. You need to set up load balancing, handle communication between servers, and ensure data stays consistent across all machines. Let us compare vertical and horizontal scaling directly. Vertical scaling is easier to implement, has lower initial costs, but may require downtime during upgrades and has a single point of failure. Horizontal scaling is more complex to set up, requires higher infrastructure costs, but allows zero downtime scaling and provides high resilience. Vertical scaling has hardware limits, while horizontal scaling is virtually unlimited. Vertical scaling is better for applications with predictable growth, while horizontal scaling works better for dynamic systems that grow unpredictably. Several important technologies help us build scalable systems. Load balancing distributes traffic across multiple servers, so no single server gets overwhelmed. Auto-scaling automatically adjusts resources based on demand, adding or removing servers as needed. Containerization packages applications in lightweight, portable containers that can run anywhere and scale easily. Microservices architecture breaks applications into independent services that can be scaled separately. Each technology solves different scalability challenges. If you want to build scalable systems, follow these 4 best practices. First, design with microservices. Break your application into independent, loosely coupled services so each can scale separately. Second, implement caching. Store frequently accessed data in memory to reduce load on your backend. Third, optimize your database using techniques like sharding and replication to spread data across multiple servers. Fourth, monitor performance continuously and set up alerts so you know immediately when something needs attention. Even with best practices, there are challenges when scaling systems. Data consistency is difficult because keeping data in sync across multiple servers is complex. Performance bottlenecks can appear anywhere in your system, and finding them requires careful analysis. Cost management becomes critical because adding more servers increases expenses significantly. And security at scale is challenging because protecting a large distributed system from threats is harder than protecting a single server. Understanding these challenges helps you prepare for them. Scalability is not just theory. Major companies use these principles every day. Netflix uses microservices and content delivery networks to stream video to millions of concurrent viewers worldwide. Amazon uses load balancing and database sharding to handle massive traffic, especially during sales events. Facebook uses horizontal scaling and advanced caching to serve billions of users globally with low latency. And cloud platforms like Oz use auto-scaling and distributed infrastructure to elastically grow or shrink based on customer demand. These real-world examples show why scalability matters.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.